How many times have you seen soldiers referring to their location with respect to some numbers or with respect to some coordinates? In movies, you would have seen this pretty often. So let's take a similar example now. Suppose we are talking about 3 army bases. And these 3 army bases are situated at these points with respect to one common reference point. So if we say with respect to a common reference point, there is an army base which is located at this point 3,8. There is another army base which is situated at this point 5,2. And there is a third army base which is situated at this point 9,4. Now these 3 bases are given in terms of their coordinates with respect to a certain common reference point. And now the question is that if we want to set up a headquarter which is equidistant from these 3 points of the army bases. So if we want to set up a headquarter equidistant from these 3, then what should be the coordinates of that army headquarter? To solve this, we need to understand the whole system of these coordinates. This is a topic called coordinate geometry. So we look at some concepts of coordinate geometry, come back and then find out what should be the coordinates of the army headquarters such that the army headquarters would be equidistant from these 3 bases. So let's move on to some concepts, learn these concepts, come back and then we'll answer this question. So to start with, let's understand the entire coordinate system. So if we talk about the 2 axes, you have the x and y axis which intersect at a common point called the origin, and hence the entire space gets divided into 4 quadrants, and these are the first, second, third and the fourth quadrants. So this entire coordinate system, also known as the rectangular Cartesian coordinate system, actually will now we can represent every point in terms of an x coordinate and the y coordinate. So if I have a point P here which is in terms of x and y coordinates, then the x coordinate of the point P would be the distance of that point from the y axis, and the y coordinate of point P would be the distance of that point from the x axis. Now when we represent points in these 4 quadrants, in the first quadrant x and y are both positive, in the second quadrant x is negative and y is positive, in the third quadrant both are negative, and in the fourth quadrant x is positive and y is negative. So when we put down a point in terms of x and y coordinates, the sign for the x and y coordinates would depend on which quadrant does that point lie in. The x coordinate is also known as the abscissa, and the y coordinate is also known as the ordinate. And then if the point lies on one of these 2 axes, so for example if the point lies on the x axis, then the y coordinate of this point would be 0, whereas if there is a point which lies on the y axis, then the x coordinate of this point would be 0. So this is the entire coordinate system where every point is represented in terms of 2 coordinates, x and y coordinates, with signs depending on which quadrant that point lies in. Let's look at how to find the coordinates of the centroid of a triangle given the 3 vertices. So if we talk about a triangle ABC, and if we say that the vertices are given in terms of x and y coordinates as x1, y1, x2, y2 and x3, y3, and if we want to find out the coordinates of the centroid, let's just once again look at what is a centroid. Centroid is nothing but the point of intersection of the medians of a triangle. So if we draw this median AD, if D is the midpoint, and then if we draw a median BE where E is also the midpoint of AC, then this point of intersection of these medians would actually be the centroid, which is commonly denoted as G. We also know that centroid divides each median in the ratio 2:1. We are actually going to now use the formulae that we have learned. Since D is the midpoint of BC, we can say that the coordinates of point D would be x2 plus x3 upon 2, comma, y2 plus y3 upon 2. We've already learned this under section formula as how to find the coordinates of the midpoint. And now we can say that G divides AD internally in the ratio 2:1, and hence if we want to find the coordinates of point G, we would multiply 2 by x2 plus x3 upon 2, and hence we would get x2 plus x3, plus we would multiply 1 by x1, which would give us only x1, divided by 2 plus 1, and hence we would get x1 plus x2 plus x3 upon 3, and similarly for the y coordinates we would get y1 plus y2 plus y3 upon 3. So this is how we get the coordinates of the centroid of a triangle, and we can remember this now as a formula so that we can save time when we are solving problems in terms of actual calculation. Suppose we have a parallelogram given. Let's look at this parallelogram A, B, C, D, and the vertices are given in terms of their xy coordinates in this manner. There is a relationship between these x and y coordinates, and we can actually find out this relationship between these x and y coordinates. Suppose we draw the two diagonals, then we know that the diagonals of a parallelogram bisect each other, and hence it would mean that this point, suppose M, is the midpoint of BD as well as AC. So if M is the midpoint of AC, and if we go back to our formula through section formula, we would get the coordinates of M as x1 plus x3 upon 2 and y1 plus y3 upon 2. But if I also consider M as the midpoint of BD, I would get it as x2 plus x4 upon 2 and y2 plus y4 upon 2. Now since both are the coordinates of M, we can say that x1 plus x3 actually is equal to x2 plus x4, and similarly y1 plus y3 is equal to y2 plus y4. So whenever we have the coordinates for a parallelogram given, then we can take the opposite vertices and the sum of the x coordinates of one pair of opposite vertices would be equal to sum of the x coordinates of the other pair of opposite vertices, and same for y. If we look at this parallelogram and suppose we label the vertices as A, B, C and D, and suppose they are given in terms of their x and y coordinates, then there exists a relationship between these coordinates in a parallelogram. So let's try and understand the relationship. If we draw the two diagonals of this parallelogram, then we know in a parallelogram the diagonals bisect each other. So suppose this point of intersection is M, then we know that AM is equal to MC, or M is the midpoint of AC and M is also the midpoint of BD. Now using our concepts of section formula, we can actually say that the coordinates of this point M, since it is the midpoint of AC, would be x1 plus x3 upon 2, comma, y1 plus y3 upon 2. Similarly, if we say M is the midpoint of BD, then we would also get that as x2 plus x4 upon 2 and y2 plus y4 upon 2. Now since these are the coordinates of the same point M, we can say that these two should be the same, and hence the conclusion would be in a parallelogram x1 plus x3 would be equal to x2 plus x4 and y1 plus y3 would be equal to y2 plus y4, which basically means that sum of the x coordinates of these two opposite vertices would be equal to sum of the x coordinates of the other two opposite vertices, and similarly for the y coordinate. Let's try and understand the meaning of slope of a line. Now if we look at these as our x and y axis, and suppose we have a line, suppose this line has 2 points A and B, A represented as x1, y1 and B represented as x2, y2, then the angle that this line makes with the positive direction of the x-axis is called as theta, and this is called as the inclination of the line. So inclination is the angle made by a line with the positive direction of the x-axis. Now if we take tan theta, it gives us the slope of the line. So the slope is defined as m equal to, m is how the slope is normally denoted as, so m is equal to tan theta. If we are also given these 2 points on the line, then another formula for the slope can be difference of the y coordinates divided by the difference of the x coordinates. So very commonly used formula for slope is y2 minus y1 upon x2 minus x1. Now depending on the value of theta, we can have different possibilities with respect to the slope. So if this value of theta is acute, so if theta is an acute angle, then we can conclude that the slope of this line would be positive. On the other hand, if theta is obtuse, then the slope would be negative. If this theta is 0, which means if the line is parallel to the x-axis, then the slope of this line also is 0, because tan 0 would be 0. And if this line is perpendicular to the x-axis, which means if theta is 90 degrees, then the slope for such a line is not defined. Now moving on from slope, there are 2 possibilities with respect to parallel lines and perpendicular lines. So if we have 2 lines which are parallel, and if their slopes are m1 and m2, then we can conclude that m1 would be equal to m2, which means for 2 lines which are parallel, their slopes are always equal. On the other hand, if we have these 2 lines as perpendicular and if their slopes are m1 and m2, then for perpendicular lines the product of the slopes is -1. So if we are given in a problem that there are 2 lines which are perpendicular to each other, and if we know the slope of one of these 2 lines, then the slope of the other line would simply be the negative reciprocal of the given slope. However, if one slope is given and you are told that the 2 lines are parallel, then the other line also should have the same slope. So when 2 lines are parallel, slopes are equal. When 2 lines are perpendicular, product of the slopes is -1. Let's see how we can make use of equation of a line. Now suppose a line is given in terms of its general form. Then the equation of a line in terms of its general form would be ax plus by plus c equal to 0. Suppose this is the line which has this equation. It's expressed in general form in this manner. Now if you want to find the slope of this line, then the slope of this line would be given by the formula minus a upon b. So if the equation is given to us, negative coefficient of x divided by coefficient of y would give us the slope of this line. Suppose further we want to find the x-intercept. Now what do we mean by the x-intercept? X-intercept is the point at which the line cuts the x-axis. Now if the line cuts the x-axis, then at that point the y coordinate has to be 0, and hence if in this equation we put y equal to 0, we get ax plus c equal to 0, and hence x is equal to minus c upon a. So the value of the x-intercept would be minus c upon a. Similarly, if we want to find the y-intercept, which means the point at which the line cuts the y-axis, we would put x equal to 0 and we would get y is equal to minus c upon b. So if the equation of a line is given to us, from that equation we can easily find the slope of the line, the x-intercept and the y-intercept for that given line. We have seen how we can use the equation of a line which is given to us, but there are a few cases where some data is given and based on that data we need to arrive at the equation for the line. Now when we want to solve such problems, we can actually use various forms of the equation of a line, and let's look at the first form, which is called as the slope point form. Now we will use this form if in a problem it is mentioned that there is a line, suppose we look at this line, which passes through a point x1 comma y1, and suppose it is given that this particular line has a slope of m. So if the slope is given to us and if a point is given to us, then using this data we can write down the equation of the line as y minus y1 is equal to m into x minus x1. So if value of x1 comma y1 is given and if the value of m is given, then we can use this form, rearrange the terms, get everything on one side, and we will then get the equation of the line in the same general form that we saw earlier, which is ax plus by plus c equal to 0. So this is known as the slope point form, which is used when the slope is given and a point is given. Now a slight variation of this could be that the slope is not given, but another point x2 y2 is given. So we are not given the slope, but we are given 2 points x1 y1 and x2 y2. Now the only change that we need to make here is we need to replace this m by the formula that we know for m given 2 points. So then it would become y minus y1 is equal to, and the formula for slope is y2 minus y1 upon x2 minus x1 multiplied by x minus x1. So if the slope is not given, but if 2 points are given, then using the 2 points we calculate the slope, and we again use the same slope point form to write the equation of the line. If some different kind of data is given, so for example, if we have a line and we need to write the equation of this line, what is given to us is that the slope is m and it's mentioned that this point of intersection with the y-axis, which is 0 comma c, and if this is given to us. So what data has been given to us? We've been given the slope and we have been given the y-intercept. Y-intercept is the point at which this line cuts the y-axis. Then we make use of the form called as the slope intercept form, where the intercept specifically has to be the y-intercept, and this form is y is equal to mx plus c. So if the slope is given and if the y-intercept is given, we just substitute slope in place of m, y-intercept in place of c, rearrange the terms, and that gives us the equation of the line. So this is the form that we would use given the slope and the y-intercept, which is denoted as c. Finally, to write the equation of the line, let's look at what is known as the double intercept, or it is also called as the two intercept form. Now this is the form that we would use if we want to write down the equation of a line given the x-intercept, suppose that is a comma 0, and the y-intercept, suppose it is 0 comma b. So if the problem talks about x-intercept a and y-intercept b, then the way we would write the equation of this line, it would be x upon a plus y upon b is equal to 1. This form is known as the double intercept form and would be used when both the intercepts are clearly given to us. So now that we've gone through our concepts of coordinate geometry and we've understood the entire system of x and y coordinates, let's get back to this problem. These are the three locations with respect to one common reference point, and let's call these as army base A, army base B and army base C. Suppose these are the points. What we can notice out here is that these three army bases, when joined together, they form a triangle. And if we want a particular headquarter which is equidistant from these three, then we are talking about that one common point which is equidistant from these three vertices, and hence we want to find the coordinates of the circumcenter. We've already learnt in geometry, circumcenter would be the point of intersection of the three perpendicular bisectors. So what we can now do is we can write down the equations of two of these three perpendicular bisectors, solve them simultaneously, and once we solve them simultaneously, we would get the point of intersection which would be the coordinates of the circumcenter. So how do we go about it? Let's look at these 2 points B and C, and if I say that the midpoint of these 2 points B and C is represented as M, then we see that the midpoint should be 3 plus 9 upon 2, which would make it 6, 8 plus 4 upon 2, which would again make it 6. So we're talking about the perpendicular bisector passing through this point 6, 6. If we talk about slope of BC, when we say slope of BC, it would be 8 minus 4 divided by 3 minus 9, which would make it 4 upon minus 6. So it is minus 2 by 3. So slope of the perpendicular bisector, negative reciprocal of minus 2 by 3 would be 3 upon 2, and hence equation of that perpendicular bisector would be y minus 6 is equal to 3 upon 2 x minus 6. If we cross multiply, we would eventually get 3x minus 2y. We would have a minus 12 here, and we have a minus 18 on the other side. When it moves on to the other, when we take all the constants on one side, we would get is equal to plus 6. So we have one equation which is 3x minus 2y is equal to 6. Let's now look at the midpoint of AC and let's call it N. So if we want to find out the coordinates of N, it would be 5 plus 9, 14 upon 2, which is 7, 2 plus 4, 6 upon 2, which is 3. Slope of AC, so if we say slope of AC would be 4 minus 2, which is 2, divided by 9 minus 5, which is 4. So 2 by 4, which is half. And hence slope of the perpendicular bisector through N would be minus 2. And hence we would get our second equation as y minus 3 is equal to minus 2 into x minus 7, which would make it, if I take 2x on this side, 2x plus y, there is a 14 on the other side, 3 goes there, so 17. And now if we solve these two equations simultaneously, my two equations are 2x plus y is equal to 17 and 3x minus 2y is equal to 6. If I multiply the first equation by 2, I would get a 4x and a 2y. 2y would cancel off, 34. So 4x plus the 3x here, which would make it 7x, which would be equal to 34 plus 6, which would make it 40. And then I can find x, and moving on, I can substitute x into any one of these two equations and I will be able to find the y coordinate. And in this manner, I have found the coordinates of the circumcenter, which would be equidistant from the three army bases, and hence I have found the coordinates of the headquarter, which needs to be situated at that point so that it's equidistant. So this is an application of these concepts of coordinate geometry, which we can actually look at in terms of real life applications, how extremely useful these would be.